Hassler here. So hopefully you watched the 9.5 Explore. It was a chance to look at creating frequency tables and look at interpreting histograms. For the 9.5 lesson, we are going to combine looking at a dot plot, creating a frequency table, and then actually creating our own histogram, and then still looking at measures of center such as mean and median. And so this is how many hours a week do algebra students watch Netflix during the school year? We will use this class as a sample of algebra students. And actually, this data didn't come from our class. It came from a previous class, but you get the idea. So here's a dot plot that shows data from your classmates. Use this data to create a frequency table and histogram. So number of hours would be the number of hours that a student watches Netflix. And so number of hours, well, the first set I have here is 0. So I'm going to say 0 hours. And there are 1, 2, 3, 4 students who watch Netflix for 0 hours. All right, so for 1 hour, there are no students. So you can write 0 or you can just write a dash if you want. In fact, if there's no data, so no data, we don't need to include. Do not need to include in our frequency table. And we'll see that here as we move along. So 2 hours watched of Netflix, there was 1 student who watched 2 hours of Netflix. For 3 hours, there was 1 student who watched 3 hours of Netflix. The 4 spot has no data, which means there were 0 students who watched 4 hours of Netflix. I'm not going to include that in my table. I'm going to skip to 5. So because there's no data for 4 hours, I'm allowed to skip that, and I can move on to the spot where there is data. And so for 5 hours, there were 3 students who watched 5 hours of Netflix. There's no data for 6 hours or 7 hours, so I'm going to skip to 8. There are 2 students who watched 8 hours. There's no data for 9 hours, so I'm going to skip to 10. There's 1, 2, 3, 4, 5, 6 students who watched 10 hours of Netflix. Skipping 11. There were 12 hours, 4 students who watched 12 hours. Skipping 13, 14. 15 hours of Netflix, there were 2 students, and 20 hours of Netflix, there was 1 student. So I have these blanks here just in case you wanted to still fill out some of the other data pieces that don't actually have any data with them. All right, our job is to make a histogram. And so when we talk about histograms, we are talking about graphs that have bars on them. And the height of the bar tells us how often something happens. And oftentimes we will see in histograms, we will see these intervals. So you notice that I have this interval right here. So we have to stop and think about how these intervals start and stop. So like my next interval goes from 5 to 10, and my next interval goes from 10 to 15, and the next interval goes from 15 to 20, and my final interval goes from 20 to 25. And the thought is, when I come to this 5 here, does this 5 go in the first interval or does this 5 go in the second interval, right? We have these boundaries, these cutoff points, and I cannot double count my data. And so I have to be consistent in my choice, whether or not the first number in that interval goes in that interval, or if I think about that 5, that's the last number from 0 to 5, does it go in this first interval? And so all mathematicians can be consistent in their thoughts. The first number for the interval belongs in the interval. The last number starts the new interval. So 5 to 10 has 5 included, but the 10 does not belong in this second group. It's going to start the third group. So 10 to 15 does not go in the green group. 15 is going to start the next group. And then 15 to 20, 15 will go in this yellow group, but 20 is going to start the pink group, and so on. So I'm kind of just going to color code these. Another way to think about this, I'm going to include the first endpoint, and then the second endpoint starts new interval. And again, I cannot double count. So I can't put information for 5 hours of Netflix watched in both of those groups. So I have to make a cutoff at some point. Okay, so that means that when I go to count how many students watch 0 to 5 hours of Netflix, I'm going to go up to 4. I'm not going to go up to 5. Okay. And so it looks like I have 1, 2, 3, 4, 5, 6 pieces of data. I could also come over here to my table. Again, 0, 1, 2, 3. I'm not including 5, so I'm just going to box off the data for 0 to 3 hours because I don't have data for 4 hours. And when I look at this frequency gives me 6. So I can either add up in my frequency table or I can count the dots. And so that means from 0 to 5, I'm going to draw a vertical line up to the 6. At 5, I'm going to draw the vertical line up to the 6. And then I'm going to color that in. I like the colors because it helps me see where the data is coming from. All right, so 5 to 10. So that means I'm going to include the 5. 5 starts the new interval. I'm going to go up to 9, not including 10, okay? Or over in my table, 5 and 8, but I'm not including 10. And there are 5 students or 5 dots in that group. So 5 students watch Netflix between 5 and 10 hours. And so again, vertical line from 5 down to 10. Okay. All right, so 10 to 15. So I'm going to include my 10. I'm not including the 15 data. So 10 and 12 get included, but not the data for 15. If I count this up, I have 10 dots. Or if I add in my frequency table, I have 10 students. And so at 10, I'm going to draw a vertical line up to 10. Okay. For 15, I'm going to go up to 20, but not include 20. That means I only have this one group here in my frequency table with 2. And so I do have this one last group. 20 starts my new group, and there is one student who watches 20 hours of Netflix. And so here I have my histogram. Okay. So again, histograms have intervals, and the interval tells me how many people fall within that range. Okay. All right. So now let's see what I'm asked to find. It says calculate the mean and median for this distribution. And a distribution is just a data set. And so when we say for this distribution, we're just talking for this data set. Okay. And so the mean, well, I could be really inefficient or I could be really efficient. Okay. So when we calculate the mean, we have to add up all the data points, the value of those data points, and then divide by how many data points there are. So if I have 4 zeros, it means I have 0 plus 0 plus 0 plus 0. And then I have 1, 2, so plus 2. I have a 3, so plus 3. I have 3 5s, so plus 5 plus 5 plus 5 plus, and so on. I'm going to say dot, 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 because, boy, this feels really miserable, having to write out every single number. And so actually I can use either the dot plot or the frequency table and say, hey, instead of saying 0 plus 0 plus 0 plus 0, I have 4 zeros. I have a 2, I have a 3. But instead of writing 5 3 times, I could say, well, I have 3 5s. And then I have 2 8s. So instead of writing plus 8, I could say I have 2 8s. And then I have 6 10s. Well, this is good because I definitely don't want to have to write 10 out 6 times. Plus, I have 4 12s. Well, I definitely don't want to have to write 12 out 4 times. Plus 2 15s, plus 20. And so you can do what I started to do in black, but to be quite honest with you, I just feel like that takes a little bit more time. And so I'm going to go this route where I can shortcut it and write things out as multiplication. I have to divide by how many data pieces there are. And so in order to determine the number of data pieces, I can either add up all these dots or I can find the total in my frequency table. And so if I add up all the dots or add up my frequencies, I've got 4, 5, 6. Oh yeah, we have these totals at the end. So 6 and 5 is 11, and 10 is 21, 22, 23, 24. So I'm going to divide by 24. And when I total this up, I'm going to run into my median spot for a second. Sorry about that. When I total this up, I get 194 over 24, which gives me 8.08. And that's my mean. All right, let's talk about median. So median is finding that middle number. And again, I think that when you have a dot plot or a data set, you could either write that data out in a list, right? We already said that we have, sorry about that. We already said that we have 4 zeros, and then we have a 2, and then a 3, and then a 5, 5, 5, and then an 8, a 8, a 10, etc. Right? So I can write out all 24 of these numbers, and I can find, what's in the middle. Or I can find what is halfway. Okay, so I have 24 pieces of data, and if I divide by 2, I get 12. 12 is halfway. That does not mean 12 is my median. That means I want to cross off 12 data points from the left and right so that I can meet in the middle. Let me show you what I mean. So I'm going to start on the left. This first data point is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've crossed off 12 data pieces. I should be in the middle of my data at this point. I should be halfway through. But just to verify, I'm going to start on the left side and cross off 12 pieces of data as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did I miss? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I feel like I did miss something. I just didn't scroll far enough. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So I had no data left over, which makes sense because I have an even number of data. So if I have an even number of data, there's no middle number. So I got to figure out what is the middle number between, 10 and 10. Well, there is no number between 10 and 10. They're the same number, and so my median is going to be 10. And so this is just another way to approach it and say, hey, I know that I have 24 pieces of data. Halfway through would be 12 pieces of data. If I cross 12 pieces of data off on either side, I should be able to land in the middle of my data. Okay. 3 says label the mean and median in the graphs in 1. So we're going to come back up here. My mean was right here at 8. So our mean was at 8.08, and my median was right here. So they're pretty close together. And the median is truly in the middle of the data. But the mean, because there's a lot more data down between 0 and 10, it's going to pull that down a little bit. Okay. Oops. It says, which type of display would be easier to use if you had to calculate the mean and median? The dot plot or the histogram, and I would say the dot plot, you can see specific data points. Whereas in the histogram, you cannot. So the histogram only tells you how many data points are in that interval, but it does not tell you specifically which data points are in that interval. So for 0 to 5, I know there are 6 data points there, but from the histogram, I can't tell you, are they all zeros? Are they all ones? Are they split between the 2s and 3s? Whereas in a dot plot, you can see exactly what the data points are. And so I prefer the dot plot. All right, we forgot to add someone to the data set. Oh no. They watch 60 hours of Netflix per week. That's crazy. Calculate the new mean and median. Okay. Well, my mean, we already started to calculate by saying I had 194, and we divided by 24. But now I have 194 plus my new data point of 60. I had 24 data points, but I'm adding one more data point. So I really have 254 divided by 25. And when I do that, I get 10.16. All right, let's talk about the new median. And so I'm going to come back up here to my dot plot. I'm going to add 60 all the way over here, as if that is acting as though I have the correct scale on my axes here, and I don't. But I'm going to, again, think about this, and now I have 25 pieces of data. I'm going to find the midpoint, and so that would be 12 and a half. So I'm going to cross off 12 pieces of data on both sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's pretty reasonable. So 1 at the 60, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because I have 25 pieces of data, I do have one left over. It's still in the tens, okay? And so my new median is still 10. And it says, which value changed more, the mean or the median? The mean changed. And so the mean changes because of these outliers, whereas the median likely won't change if you have another piece of data added. All right, so let's go ahead and flip our paper over and just take a couple quick notes here. We've already talked about what a mean is, but we just noticed that the mean, which is the average, so I'm just going to remind us this is the average. That's a V. This is affected by outliers. So the mean can change based on outliers. An outlier is going to pull the data in the direction of that outlier. A median, which we say is the middle value. Is either not affected by outliers or has little effect, okay, or small impact by outliers. Which is why we like to use the median to describe data, because it's not impacted by outliers, whereas the mean is impacted by outliers. The other thing I want to talk about is the histogram that we made. So a histogram is a graph made with bars. Whose height, well, if I could spell, my apologies, whose height shows the frequency data occurs within that interval. And then I'm just going to say, first of all, an interval could be called a bin. I don't think I mentioned that. But when we talk about intervals, you include the left endpoint. We do not include the right endpoint. Okay. All right, so your job is to work through the check your understanding. We will work through the practice at some point in class as well. And if you have any questions, let me know.